Sometimes I wish I could just like throw my phone away, like not come to school, like hide.
I get it. Do you guys remember the formula that I gave you yesterday? So here it is, and I'm only writing it down again because I want to have a quick chat about it with you. If I lose you, this part of the lesson is completely, from my teacher perspective, it's optional, but I feel like I owe you this. So this is the formula that we talked about yesterday. There's one variable up there that's of most interest to me, and it's n. Do you guys remember what n is? Attaboy. So what happens is like your interest doesn't just have to compound once a year. So if it compounds annually, that's end of story. The Trinity's got her account and she gets interest, say in December, and then the account sits and it waits and it gets more interest in December, and then it goes again. So that's annual. So in a case like that, n would be 1. That means that the compounding is happening 1 time per year. But as we proceed through the lesson today, I'm going to change that and we're going to get different types of compounding like semi-annually. What does that mean? Twice a year. Semi, the prefix semi means every half of a year, which means 2 times per year. So when that happens later in the lesson, n is going to become 2. What about quarterly? Yeah, 4 times every quarter. So every 3 months. So Trinity now gets her interest in March, and then she gets it in June, and then she gets it in September, and so on and so forth. So, and then compounding can keep going beyond that. What if it's monthly? Then n is 12. And we're probably going to stick mostly to those. I will get a little bit brave and take us to daily compounding. What's that going to be? Right. And if you want to be technical about it, you should always use 365.25 for that n value because that factors in that every 4th year is an extra day. But 365 for most people is just fine. Anyways, the point I wanted to make is this. If so, we start today's lesson with annual compounding, which means that n is equal to 1, right? Now, I want you to take a look. If this part loses you, just let me know. If I take n and I make it 1, really important, pay attention now. If I put a 1 right here and right here, I want to show you right now that there's a modified, simpler version of this formula that you're allowed to use sometimes. So what is in this purple box? You really cannot get through this part if you're daydreaming. So perk up, listen. If I change n right there into the number 1 like this, what is r divided by 1? It is r. So in this particular scenario, if the n value equals 1, you will see versions of this formula where instead of seeing r over n, you might actually only see r. And I said, wait, that's not the formula that Mr. Ahern taught me. It is if n equals 1. And also, if compounding happens once a year, there's another place where I can put a 1. I can take the number 1, follow this yellow arrow, and I can put it right up here. And if I change that n up there into a 1, what is 1 times t? Good. So I'm telling you this because I care about you, and I don't want you to think that I lied to you. But if you ever are working through, say you go to take like some test prep book in college, or I don't know, but somewhere along the line, let's say you see that red formula right there. That is the formula that we're working with, but it only works when n equals 1. Got that? So if that confuses you, then I guess you just have to probably erase your memory from everything I just said and know that you can always use this formula. Just know that sometimes if n is 1, whether you know it or not, you're actually just using the red formula, but it all comes out in the wash. Got it? So if you're working in your IXL here in about 20 minutes when I get done with this and I cut you loose and you happen to see this red formula, don't think that anyone's lying to you. It's just the simplified version of the white formula for a very specific case. All right, good. So having said that, let's get to it. So let's just do math problems. Again, without a calculator today doesn't happen, so make sure you have one. Let's say that we invest $5,000. And that seems like a lot to you guys, and I get that. But let's say like you graduate from high school and your grandpa's been holding out on you, and on the day you graduate, he says, "Hey, I wanted you to have this," and he gives you $5,000 to get your life started. So you're like, I'm not going to go blow it. I'm going to go put this in an account. So you invest $5,000. And let's say the account that you put it in, we'll say gets 6.5% interest. And for the first couple of examples, we're going to just stick with once a year compounding. So that 6.5 is just going to be annual compounding. All right, so you get $5,000 from your grandpa, and then you invest it, you get 6.5% per year. And let's say you just let the money sit there straight up for 45 years. You just tell yourself, I am not going to go touch that money until my 63rd birthday. 18 plus 45. You say that's going to be money for me when I hit 63. That'll be a gift from grandpa to me. So we're going to use our formula, and you want to get really good at the formula. So we're always just going to write A equals, and here we go. What are we going to put in place of P? Nope. 5,000. P is what's called the principal. That's what the P stands for. It's just we know it as what we start with. So the 5,000 will go there. And then in parentheses, we're going to put 1 plus. And then what are we going to put up on top of the fraction? If you put 6.5, that would mean 650% interest, which is nuts. Be good, but nuts. 0.65 is still too big. It's 65%. Yeah, it doesn't matter how many. Like, I hope this one. Yeah, like it never changes. It never changes. If there's still humans alive on this planet in 200 years, if we somehow survive the next 200 years, and there are still humans doing mathematics, the rule will still be that you move the decimal 2 places to the left or to the right, depending on what you're doing. We clear? So when I write the number 6.5% and I want to convert it to a decimal, I will move it faithfully 2 places to the left. And note that when I try to do that, there's an extra ghost space here that the decimal always has to have something to hold on to as it moves. And that's why the need is here for this extra 0. That cannot be something that we kind of hit or miss. That has to be hit 100%. Move the decimal twice to the left, always twice. So the number I'm going to put up on top is 0.065. And then I'm going to divide it. And again, this is where, if you know what I'm talking about, you know that right now what I'm about to do is pretty dumb, but I'm going to do it. I'm going to put it divided by 1. And why am I putting a 1 there? What letter did I just replace with 1?
You come after me for.
I'm replacing the n, and I'm saying that n is 1 because in the problem we mentioned that it's just compounding annually, 1 time per year. Here in a little bit, I'm going to change that, and that's going to become a different number. But thank goodness that we have calculators. And then in the exponents, I'm going to do n times t. And we know that n is 1. So if n is 1, and what's t? 45. And what's 1 times 45? Good job. So this is where we grab our calculators now and we type this in. And most of us are going to be using the TI-30 kind of ish calculators. So the way it's going to look on your screen is going to be, again, I'll write this in purple. You type in 5,000, and then you don't have to put times. Your calculator knows if you jump right to parentheses that it's going to multiply. And then you're going to put in 1 plus 0.065. And yeah, listen, if you want to divide by 1, you get down with your bad self. I, as a man of principle, refuse to do it. So I'm not going to do it. And then I'm going to close my parentheses. And then I'm going to put to the power of 45. And I'm going to type that in just so I can make sure that we're all on the same page. Grandpa's gift turned out to be pretty cool. And if that's assuming that I can afford to just put it there and forget about it and say, I'll be back in 45 years. So grandpa's gift of $5,000 when I'm ready to say retire or maybe move on and buy a different house when I'm 63, grandpa's gift of $5,000 is now worth $85,055.49, which is pretty dang good. Thanks, Gramps. So that's how compound interest works. And the thing about that, what people don't understand sometimes is that None of the exciting stuff happened in the first 30 years. Like if you were impatient and Aiden went and he's like, I got to check my account and see if it's growing. If he goes when he's 38 and he checks his balance, he's going to be like, this sucks. My math teacher lied to me. His account's going to have garbage in it. Because that, like I showed you that curve yesterday, none of the exciting stuff happens until that growth is given a chance to click and take fire. So you'll hear people tell you, invest while you're young, invest while you're young. You know, it's like the trendy thing to say. And the reason people say that is because if you wait to start investing until you're 35 or 40, then by the time the exponential curve hits the good part, you're 80. And that's beyond the point where we want your money to start accruing lots of value. So if you hear old people tell you to go and start investing, even if it's just a little bit, it's not just because it's a trendy old person thing to say. The mathematics is spot on. So if you can even afford a couple $100 when you're 18, put it in, forget about it, walk away.
Wait, what would
Come back.
interest?
Listen, let's do the same problem again. And let's modify a couple things just for giggles. So let's say that grandpa let's say you had a grandpa that was a little not quite as wealthy. So let's take grandpa's gift of $5,000 and let's say grandpa could only afford to give you $3,000. So grandpa, but that was huge for Gramps. Like that was a lot for him. But to offset that, let's say that you had better fortune and were able to figure out a way to get your money to accrue interest at a higher rate. So let's say instead of 6.5% interest, you got 8.5. So what do you think is going to have a greater impact? Grandpa's lessened gift or the higher interest rate? Are you expecting a bigger answer with the higher interest rate? Because grandpa only gave us $3,000. Who's going to win? Is the minus $2,000 in the initial gift going to outweigh the power of the extra 2% interest? So when we go to type this in, instead of typing in 5,000 at the beginning, we're going to type in 3,000. And instead of 0.065, we're going to type in 0.085. Let's check it out. Yeah, let's keep the same period of time. What'd you see? $117,000. So the moral of the story is, which has a greater impact, the initial value or the interest rate? Interest rate is huge, right? So lessened gift, we got 30,000, 32,000 more dollars when all said and done because we found a better interest rate. Good. Are you ready for that? You guys ready to start changing N? I don't want to go too fast. Are we comfortable with this process right now? Like how to type this in and everything? Are you okay? You sure?
Mm-hmm.
So here's the deal. We're going to go through this exact same process, and I don't really care. We can stick with grandpa. I kind of like to take the same scenario and just kind of monkey with it so you guys can see how different things have different impacts. By the way, interest will play the most significant role. So when you hear people talking about like the housing market and interest rates, like it's because it's the thing. It's the only thing. Interest is what determines everything. So but anyways, this will have an effect, but it'll be pretty minimal. So let's say you find a way to invest your $3,000, you get a return of 8.5% interest, and you still keep it in there for 45 years, but you're going to get your interest returned quarterly. And what that means is now I'm not just getting interest like once a year. So here's a misconception. So let's just make this simple on ourselves. So let's say that we get interest in March, and then we get interest in June, and then we get interest in, what is that, June, July, August, September, right? And then that would have us getting interest again, October, November, and December. So quarterly might look like this. It doesn't have to be those 4 months, but it literally means 4 times a year. So here's a misconception that people sometimes have. They say, oh, this is rad. So are you telling me that I get 8.5% interest in March, and then I get 8.5% more interest in June? And the answer is, of course not. That's not 8.5% interest anymore. That's 34% interest, right? So what happens is the 8.5% interest gets divided into 4 pieces. So if this is Diedrich, he's not going to get all 8.5% of his interest. He's going to get a fourth of it. So like 2.125, I think is what that comes down to. So you're going to get 2.125% in March. You're going to get it again in June. Does that make sense? So you're still getting your 8.5%. It's just, it's being divvied up into 4. So a smart person at this point, if you're really listening and not daydreaming, would ask the question, why does it matter? Like, what's the difference? If you're going to give me 8.5% over the course of the whole year, or you're going to divvy it up into little baby slices, why are we even having this conversation? Do you think it matters? It does. And what's interesting about it is, if you think about it, is if your account gets a little bit of interest in March, then the next time it accrues interest in June, you get a little boost because of the interest you got in March. And then in August, you get an even bigger boost because you've already gotten the boost from March and June. And then in December, you get the ultimate boost because you've gotten little baby packets of interest in March and June and August, or whatever, September. Are you picking up what I'm putting down? So the moral of the story is, it does matter. Because it's compounding, it does matter. And you can even take it next level and say, do you think it matters more if it compounds more often? It does. Eventually you get to a point, and I don't know if we're going to talk about it in this class, but we certainly can. Interest can actually compound, ready for this, continuously. It means it's always compounding. So imagine if your interest compounded once every second. Can you just even imagine that? Now imagine if it compounded 100 times every second. Now imagine if it compounded 1 billion times every second. That's called continuous compounding. And that's a totally different form. But we're not going to talk about that today. Yeah. You'd have to have 34% interest. Right, because that 34 would have to get divvied. It was, having had that conversation, if you're in that conversation and listening, what I'm about to write will make perfect sense. Here it goes. So when we take this formula and we modify it for quarterly, here's what Grandpa's new formula is going to look like. This is so cool, I think. We're going to write A equals, it's still going to be 3,000, boring, and it's still going to be 1 plus. What's going to go on the top of our fraction? Which is? Good for you. But this is, I think, the part where it all kind of comes together. What's going to go on the bottom? And that's exactly what you just saw, is that 8.5% is being divided by 4 because you get a fourth of it 4 times a year. So cool. Right. And so our exponent is going to be a lot bigger, because now I think about that exponent and it's n times t. What's n? What's t? What's 4 times 45? You bet your butt it is. And that's what our new formula is going to look like. Think about that. It makes perfect sense that if something happens 4 times per year and it happens for 45 years, no, it happened 180 times. I love that math. Beautiful. So do you guys are taking notes. Do you remember? Oh, I have it on my screen. So when we did Grandpa's annually, I'm going to write it in yellow up here. When we just had Grandpa's money annually, we got $117,885.25. You might think this is going to make a big difference and you're going to be disappointed. Will it be better? Yeah. Will it be a lot better? No, but it does matter. So type it in. Make sure you're typing these in. It'll help you to stay awake and it'll get you good at typing these in. So 3,000, and then in parentheses 1 plus 0.085 divided by 4 to the power of, holy smokes, 180. And this time, it's better, isn't it? So the new answer, I'll write up here, I'll write down here in purple, and it's 132,000. And I'm actually really surprised that it made that much of a difference. Huh. That's amazing. I didn't think it would.
It does change it quite a bit.
Normally it doesn't. And that's why in this case, I was surprised to see that. And it could just be the duration, could be the good interest rate. But look at that. If we get the 4 times per year, we made almost $15,000 more off of Grandpa's gift, which is pretty cool. Again, you could take this next level. Once you know how to put it in your calculator, you think compounding daily, that could be scary, but what's scary about that? You just change all the ends into 365s. Call it good. 0.25. Right. So far, so good. Is there anything about grandpa's problem you want to try and experiment with and change again? Are we comfortable with the process? You hit it all, you said? I think not right now. No, no, that's it. No, maybe a little bit. It's like we got the bulk of it out of the way. Like you understand where to put P, you understand where to put R, you understand to move the decimal 2 places to the left. You know that N is going to be the number of times per year, and you know that your exponent is number of times per year times the number of years. Calculator village, baby. I wrote this down because I knew I would have to go figure it out again, but here it goes. I'm going to write this on the board. This is the IXL skill that I want you guys to master today. Q S F. So you know how it works. You go to IXL, search that skill. It's going to pop up, and you're going to knock out some maths. You still having a good day?
What?
You having a good day? You said earlier you're having a good day.